Ahoy there makers! I've been playing around with OpenClaw, the AI assistant that's been taking the internet by storm. I set up OpenClaw on my Mac Mini M2 and named it Milton, just 2 weeks ago. I actually named it after the Simpsons character. I thought it was called Milton. He's called Milhouse, obviously. Not the English poet, but both work. I asked Milton to write some Python programs overnight and surprise me. By morning, he built a smart project documentation tool that analyzes my code, detects components that are used, and generates a bill of material. Actually quite impressive. But Milton also decided my family needed hourly updates about Python projects. My daughter was trying to navigate London train cancellations. Milton was sending her servo motor specifications and snarky replies. I shut him down Sunday evening and checked my bill. My GitHub Copilot Pro, which has 300 premium requests, had been completely consumed within 48 hours. By Milton and another agent I'd created called Eve. That's when I realised OpenClaw wasn't just expensive, I just didn't understand it at all. Over the next week I discovered 3 massive problems and how to fix them. This is the complete story. My name's Kevin, come with me as we build robots, bring them to life with code and have a whole load of fun along the way. So I checked what was actually happening. Every OpenClaw request includes the entire system prompt, not a cache, the full thing every time. Here's what gets sent per request. The system layer has 5,700 tokens for prompt, 3,500 for tool schemas, 1,500 for descriptions. That's 10,700 just for infrastructure. Then there's your workspace, your solder MD, agent, identity, user, memory, another 3,000 tokens. Session history, your conversational context, easily 50,000 plus tokens if you've been chatting. So that's a total of between 20,000 and 30,000 per request just before you even start typing anything. Now heartbeats, OpenClaw wakes up every 30 minutes and sends the entire context just to ask, is anything urgent? 48 heartbeats per day, that's another 25,000 tokens, which at $5 per million input tokens on Opus 4.5 is about $6 per day. So 180 per month, just for idle checks. My 2 agents running simultaneously meant 96 heartbeat requests per day. Between them, they were sending nearly 2.4 million tokens daily before Milton and Eve had even had a single conversation. And that's just input tokens. Factoring the output tokens at $25 per million, and the real numbers climb higher still. The first problem, a default OpenClaw architecture, is very inefficient. The second problem is security. While I was investigating the cost, I found out about a security audit that just happened. Koi Security audited ClawHub, the marketplace where you get OpenClaw skills from, which are like plugins. They found 341 malicious skills out of the 2,857 total. That's actually 12%, and 335 of them came from a single coordinated campaign. How does it work? You see a skill called YouTube Summarizer. Looks professional, but there's a prerequisite section that says download and run this file first. This file is a Trojan. It installs a keylogger, it steals your API keys, your SSH credentials, everything. One skill opens a reverse shell, giving an attacker full remote access to your machine. The second problem is that ClawHub has zero security vetting. But there's a third, a critical vulnerability in OpenClaw itself. CV 2026-25253 has a CVSS score of 8.8. One-click remote code execution. If you click a malicious link, just click it and attacker can steal your authentication token, disable your sandbox, and execute arbitrary commands on your machine, all in milliseconds. This was patched at the end of January 29th, but if you're running an older version of OpenClaw, you're definitely vulnerable. The community is responding. Koi Security built ClawDex, a free tool for scanning for malicious skills before you actually install them, and OpenClaw added a reporting system where skills and multiple reports get auto-hidden. But the fundamental problem remains. ClawHub was designed with zero security barriers to entry. Anyone with a GitHub account can upload anything. So the risks are real. Malicious code, execution exploits, prompt injections. But here's the thing, they're all mitigatable with basic hardening. And this is an open source project, it is an ongoing project, and it is obviously improving. Open source projects tend to go through a couple of phases. First of all, we try and make the software work. Once the software is working as a proof of concept, we then try and make the software right. That might include documenting the code, refactoring code, and also critical security updates. Finally, we'll try and make the software fast, and we'll optimize it so that it makes the most out of the resources available. Okay, so I had a cost problem and a security problem. Both of these are fixable. Here's what I did. First, I understood the cost structure. Not all requests are the same. The Heartbeat doesn't need a Claude Opus, just checking email. That can run on Haiku. So I created a routing strategy. The main conversations use Opus for complex reasoning. Heartbeats use Haiku for simple checks. Memory updates, again they can use Haiku. Email filtering, Gemini Flash. Super cheap. Then second, I reduced the heartbeat frequency. The default is actually 30 minutes. I changed this to every 2 hours. Fewer checks means lower cost. The agent still stays on top of things. And third, I cleaned up the context. Every conversation adds to the session history. I started resetting the sessions after completing tasks. This reduces the per request token overhead from 25,000 down to about 12,000. And fourth, I use the OpenRouter's auto routing. Instead of manually picking models, I configured OpenRouter's auto setting. It automatically selects the cheapest model that can handle each request. Simple prompts go to Haiku, complex go to Opus. So for my optimized setup, heartbeats are on Haiku, conversations are on Opus, memory is on Haiku, and cron jobs use Gemini. It's about a 40% reduction from the smart routing on the heartbeats memory, but I went further at reducing the heartbeat frequency and stripped out context. So Milton handles the conversations and coding and is connected to iMessage, Slack Obsidian, uses Opus for important work, Haiku for housekeeping, heartbeats every 2 hours with a very trimmed down context. Eve is my second agent that runs on the Raspberry Pi 500 behind me just there. She can connect to my Gmail, Discord, and she uses Sonnet for conversations, Haiku for everything else, and has a heartbeat every 4 hours with very minimal context. So quite cheap to run that one. That's about a 95% reduction. And here's the security part. I installed ClaudeX to scan any skill that I install. I enable the sandbox mode to run untrusted code in Docker containers, and a restricted tool access. My agents don't need shell access for everything. Now, I did try installing OpenClaw on this Raspberry Pi, which has the AI Hat 2 installed on it that can run large language models. One of the issues I came up against with this was that there is actually a limit to how many tokens that you can actually process with the AI Hat running Ollama. The version of Ollama that the AI Hat is running is a Halo version, and it has some hard-coded limits on there about the prompt size that can be sent. And that meant that I couldn't use OpenClaw with the AI Hat. It's really disappointing because I was hoping to do this kind of for free. It's a bit of a false premise though, that because the kind of AI that can run on a local instance is not quite the same scale as one such as Claude Code or the brand new Opus 4.6 from Anthropic AI. So I tried it and unfortunately it didn't work. If you want to know more about that, let me know in the messages and I might do a bit of a deeper dive. Here's what I've learned from the whole thing. OpenClaw is genuinely powerful. It builds code, it makes decisions, it's proactive, but the power without economics is just expensive. The maker community especially needs to understand this. We need to think about hardware costs. Raspberry Pi is $80, sensors are $20. We calculate cost per project, but Cloud API feels intangible. I've never really worried about it myself until this project. Intangible, infinite even, until they're not. If you're going to run OpenClaw long term, you need to treat it like infrastructure, monitor it, route intelligently, and understand the mechanics. The good news is, once you understand it, it's really manageable. My current setup with 2 agents, fully functional, sustainable cost is something I can now run forever, about $11 per month. It's cheaper than most SaaS subscriptions. Easy for me to say. It's cheaper than most SaaS subscriptions, but you have to know the mechanics first. The security risks are real, but they are mitigatable with basic hardening and using some of the security tools such as Claude-Dex. Capability without efficiency is just expensive. Combine them and you've got something really special. If you're experimenting with OpenClaw, don't be scared of the cost, just be smart about them. Understand what you're paying for, route intelligently, and monitor your usage. Implement basic security hardening, and then OpenClaw is genuinely remarkable. But it does require you to be a bit thoughtful about how you use it. When I initially had it running these overnight building things, I didn't really think about the cost, and I've used up a lot of my tokens in a very short amount of time. I'm going to make a more detailed video about OpenClaw optimization in the future, and this is definitely a project I'll be keeping a close eye on. So we can cover things like security hardening, multi-agent setups. If you want that, subscribe and turn on notifications, and also if you're running OpenClaw and you figured out something clever, drop it in the comments. I'm always learning. So thanks for watching, and I shall see you next time. Bye for now.